Natural selection is when nature selects. Again, not choosing, but just through the harsh environment determines who gets to pass on their traits to the next generation. So go back to the example of dogs with puppies. So an organism has a litter of puppies, in this case dogs. They're not all the same. Different color, different size, different shape, different fur types. You know this. Now those with traits who fit better for the environment in which they live are going to be more likely to survive and mate and pass on their traits to the next generation. So again, fitness depends on their particular environment. In a cold environment, let's say, long fur would be more fit, right? In a colder environment, having long fur would be better. They'd be more likely to survive. In a warmer environment, though, to be more fit, it would be more fit to have short fur. So puppies with short fur are going to be more likely to survive in a warmer climate like that. So only those that survive, obviously, are able to pass on their genes and pass on their traits to the next generation. And this same thing happens over and over and over again through multiple generations. And what happens in this particular environment, let's say, in a warm environment, those with short fur, that becomes the dominant trait, because that's what's best suited for that particular environment. And so if you go to a place that has a warmer climate like this, you'll see that virtually all of the dogs have short fur because of that natural selection process that has gone on for hundreds, thousands of years. And so they've adapted to their particular warmer climate. The question then becomes, how powerful is this evolutionary process? Everything I've said up to this point is not controversial. Everybody agrees with what I've presented so far. This is just a fact. This is what happens in nature. We can all observe this. We can all see this. All sides agree what I've described so far does take place. The question then becomes, the question that's a bit more controversial is, how powerful is this process? In other words, through enough generations, what can this process accomplish? Well, everybody agrees that this process is pretty powerful. It can produce radically different organisms from a common ancestor. I mean, just think how different breeds of dogs are around the world. I mean, there's two extreme examples. Through the process of natural selection, radically different organisms can be produced. Case in point, we see all these different types of dogs around the world. However, is it powerful enough, given enough time, is it powerful enough to create a completely new type of organism? Is it powerful enough to produce a completely new type of organism? This is the question that is a bit more controversial. Darwin, as you know, speculated that it is in fact powerful enough to produce brand new types of organisms. And that is why his book was titled On the Origin of Species. Because he proposed that this process, given enough time, would produce completely new species. And this is what has been controversial. This is what people have disagreed with over the last 150 years plus. Let me pause here and give you guys a discussion question. I like to break every 10 or 15 minutes and let you guys discuss something with your neighbor. Kind of breaks up the morning a bit. Helps you then listen better when I get back to talking. So here's your discussion question. Just talk to the people around you real quick. I'll give you a couple minutes. Do you think it was, and I worded this question very carefully, so pay attention to how I worded this. Do you think it was reasonable for Darwin, based on the small-scale evolution he observed, to propose the hypothesis that this process could produce new species? In other words, given enough time, would produce large-scale evolution. So go ahead and discuss that with your neighbor for just a couple minutes here. All right. Right, as you've noticed on the screen, I think the key word here is reasonable. And I would say, yeah, I think it is a reasonable hypothesis. Note that I didn't say true hypothesis, but I would say reasonable. And especially given the historic context in which he lived. You have to remember he was in the early to mid 1800s when he was doing his scientific research. And what had recently been such a huge boon in science was Isaac Newton's theory, right? And so here you do have a classic example of somebody observing something at a small scale, right? The classic story, Isaac Newton seeing that an apple falls to the ground, and speculating that that effect, or that what he's seeing at a small scale, i.e. gravity, might explain what's going on a larger scale out in space, the solar system. So that was revolutionary, but in fact was a true hypothesis, which eventually was verified, that the way gravity works here on Earth is why the planets and the sun and such work and function as they do in our solar system. So looking at something and seeing it on a small scale and then theorizing that it also takes place on a larger scale was a very common approach and sometimes paid off, as this famous example with Isaac Newton. So I think it was reasonable for Charles Darwin to put forward this hypothesis. You might remember the famous story of him observing this process taking place with finch beaks, right? When he was on his famous trip around the world, traveling on that boat, he observed these finches and how their beaks would change depending on the environment that they were in, the harsher environment, whether it would be better for them to have shorter or longer beaks, and they would change and adapt. So he saw this process take place at a smaller scale and postulated that eventually enough of these changes might add up to produce a completely new species. That was his theory. Now, sometimes the difference between a small-scale evolution and large-scale evolution is called micro and macro evolution. So if those terms come up, that's all I mean by it. Small scale, micro, microscope. Macro is a big scale. Think of your Big Mac at McDonald's, right? Macro. So micro versus macro. Those are common terms within this literature. The question then, with his hypothesis then, is it correct? Is it true? Is this process powerful enough to create completely new types of organisms? Or is there a limit to it? Is there some sort of edge over which evolution cannot go? Is there some sort of limit or edge? And I want to direct you to a particular scientist who makes this case. His name is Dr. Michael Behe, and he presented compelling evidence, I think, that yes, there is a limit to this evolutionary process. That's why his book is called The Edge, or The Limit of Evolution. Now, Dr. Behe got his PhD in biochemistry from the University of Pennsylvania, and he is a professor of biochemistry at Lehigh University. And I think his arguments are the strongest arguments against evolution. So I want to go through a couple of them with you this morning. He argues that since Darwin's day, we, through our science, have discovered so many additional things that Darwin was not familiar with, which shows that there's a limit or an edge to this process, a limit to the changes that evolution can produce. As I said before, one of the key aspects of evolution is to have variation among the offspring, right? So when an organism has offspring, there has to be variation among those offspring for natural selection to even begin process. Give natural selection something to latch onto to select or either non-select. Without variations, there would be nothing for nature to select for, and the process wouldn't work. So as Darwin himself even wrote, unless there are profitable variations, natural selection can do nothing. Now, in Darwin's day, in the middle of the 1800s, there were a lot of things that Darwin and the other scientists did not know or did not understand. For example, during his day, they did not know the answers to these questions. They didn't know what caused the variations among offspring. They didn't know how much these variations could actually vary. And they didn't even know how these variations or traits got passed on to the next generation. So there was a lot that they didn't understand about this process. And what Behe does, again, as a professional scientist, I'm not. My training is in other areas, so I have to lean on professional scientists for a lot of this material, and I lean on Dr. Behe. But what he's shown is that scientific discoveries over the last 150 years, as we've learned the answers to these questions, show that there is in fact a limit or an edge to what this process can accomplish. One of the most important discoveries was the discovery of genes. We discovered in the 1930s, so 70 years after Darwin's book was published, we discovered that you're actually wearing mom jeans. And your dad's genes too, but you're wearing your mom's genes. We learned in the 1930s that genes were the basis for these variations that get inherited by the next generation. Organisms' offspring, they inherit random mixtures of their parents' genes. That's what causes these variations. Now, for every organism then, each parent contributes half of their genetic code, right? So mom, half of your genetic code came from your mom, the other half came from your dad. But as you know, with your siblings, there's differences because you get a different half from each parent every time. So there's a shuffling process going on, if you will. You get a different combination each time a new offspring is produced, and that's what causes the variety. We discovered, as we made these scientific discoveries, we learned that the genes themselves are not changing, okay? The genes aren't changing, they're just being reshuffled in different combinations. So you have a certain combination of half of your mom's genes, half of your dad's genes, but your sibling has a different combination of half of your mom's genes and half of your dad's genes. That's why siblings are different. In other words, no new information is being created. There's just a shuffling process going on here, which causes different traits, different heights, different weights, different hair colors, different eye colors, etc., etc. All the traits about your physical and mental self is because of the shuffling of those genes. And this is why horse breeding, for example, can produce very different types of horses. So professional horse breeders, they're not adding anything new into the gene pool. They're not creating new information. They're just selecting certain combination of genes that are better, maybe in their case, to create faster horses. So they're just trying to bring certain traits to the surface by choosing genetic info or choosing traits, choosing genes from a larger set of genetic information that's already there in the gene pool. They're just trying to bring it to the surface. Similarly then, in the process of natural selection, no new information is being created. There's just a reshuffling of the genes that are bringing better suited traits for that particular environment they're in to the surface. And that allows the species to then adapt over time to their particular environment. We've been using the example of dogs because that's really easy to get our minds around. So in a cold climate, dogs eventually, over enough generations, are going to develop, by this process of natural selection, longer fur that will help them survive in that harsh environment. And that process is taking place. We all agree. So with these discoveries of genes and other discoveries, now that we know better how these traits are passed on to the next generation, People have learned then that this can't explain the origin of new species because there's no new information being created. It's just a reshuffling of information that's already there in the gene pool. So those who still hold on to evolution came up with another theory. They said, okay, it's not just the genes that are passing along. There's got to be new information introduced in some way, shape, or form. Because to create a brand new species, there has to be more information than just what's there in the gene pool. So how does this new information come about? And this is the new theory that then has been presented, the theory of mutations. So this idea now is what has been partnered with natural selection to be the modern theory of evolution. That it's mutations in the gene pool that create new information that over time would lead to new species. They claim that this is the key ingredient which provides the new information to go from microevolution, which we all agree to macroevolution, to create brand new species. Micro happens with existing information, genes already there being reshuffled, but they're claiming now that for macroevolution to take place, to really build something new, there has to be new information from somewhere, something that's not already in the gene pool. And they're claiming that mutations then provide this new information. So they claim that when an existing gene has one of these accidental mutations, a mistake, if you will, they think this new information can serve as the fuel to drive the macroevolutionary process. So in microevolution, the fuel is the genes being reshuffled around. But for macroevolution to take place, they claim it's these mutations that allow new species to develop. So let's talk about this for a few minutes. What is a mutation? Well, it sounds just as bad as it is as bad as it sounds. A mutation is not a good thing. A mutation is a random change that occurs at the molecular level in DNA. It can be caused by all sorts of things like radiation, viruses, chemicals, errors in the DNA replication process. So all sorts of things can cause these accidents to happen in the gene, in the DNA, these mistakes, if you will. The key question to ask then is it possible to build something completely new and complex, say the human eye or the human brain, from small step-by-step accidents, where each accident in and of itself has to be useful enough, not just the end result of multiple accidents in a row, but each mutation, each accident has to be useful enough for nature to select it and pass it on to the next generation. Now keep in mind, natural selection cannot work like artificial selection. Artificial selection has a breeder, right, a human being, who's thinking down the road and saying, I want such and such horses. I want fast horses, and so then can do things to achieve that goal. Natural selection isn't conscious, so it can only work at the level of selecting something that's useful for that particular organism to help it survive and mate and pass on its genes to the next generation. So each accident has to be useful, each mutation has to be useful in and of itself.